With partial derivatives and the gradient, we are now ready to take directional derivatives. This is the directional derivative, the slope of the surface in any given direction. The direction is always going to be specified by a vector. We actually need it to be a unit vector. So before I do anything else, let's make this a unit vector. The unit vector for this is the same vector divided by its length. And its length is the square root of 9 plus 4. So we have 3 comma 2 divided by the square root of 13 as our unit vector. That unit vector is the direction that we're interested in. We want to know the slope of the surface in the direction that that vector is pointing. To find the directional derivative, now that we have the unit vector, we also need the gradient. So the gradient of f is the derivative of f with respect to x, which is 2xy, and the derivative of f with respect to y, which is x squared. So that's our gradient. We are interested in the directional derivative at the point 1 comma minus 2. So our gradient at 1 comma minus 2, we just plug in those values for x and y. Plug in a 1 for x and a negative 2 for y, and we get negative 4 comma 1. So that's our gradient, and this is our direction, and the directional derivative is the dot product. So the dot product is negative 12 plus 2, so negative 10 over the square root of 13. That is the directional derivative and our answer.